Hey, Addison, we're going over questions on R1, and I figured I'd record and send those to you. If you don't have these questions, that's fine. Just check your answers and stuff. But I figured I'd record this, and yeah, and then we'll start in notes for R2. Okay. So they had a question on 42. So I'm gonna sketch out just real quick what. Oh man, not that. Pull them back down. Yes. Y is greater than or equal to -3. So -3 here, circle, and this way. That's what he looks like, right? Okay. Greater than or equal to 5, closed circle to the right on that one, and less than 0, so open circle to the left. That's what he looks like individually. All right, so on part A, they want M unioned with N. So I want like these guys together. That's kind of weird. So for part A, I'm gonna map him down here. I've got -3 here. I've got 5 here. Closed circle, this way, this way. If I union them together, what do they own? They own all of this, right? Okay, so from -3 to infinity, bracket here, paren. Yeah? Part A, okay? M intersect N, so where do they overlap? Nope, they don't overlap from 3 to 5. They overlap from 5 on, okay? So 5, comma, infinity, bracket, paren, right? Okay. M, do we have any others? Okay, so now we're getting into the P's. Okay, so now we have M union P and M intersect P. Okay, so on M and P, we got -3, we got 0, we got open circle this way, closed circle this way. Now, if you're graphing these, be very careful. Make sure that you're putting the arrow going all the way to the right and you're not just connecting between them, right? That arrow goes all the way to the right. So union, what do we own? All of it, even the 0 that's covered up? Yep. Yeah, because the -3 guy owns him, right? Okay, so we own all reals, or you can say negative infinity to positive infinity. Okay, either way you want to say it, we own everything. All right, now, the intersection, where do they overlap?
-3 to...
From here to here, that's where they overlap, right? So from -3 to 0, brackets or parens?
Bracket on the left.
Bracket here, paren there, right? Okay, that's for this. That's for part D. Okay, and then I'm going to do N and P together. So N is 5 and P is 0. So I'm going to put 0 over here, 5 here, 0 here, 5 here. Okay, the union. If we're doing this one, the union, what do we own? This one's a weird one because they don't overlap, right?
Negative infinity to 0.
Negative infinity to 0.
Both paren.
Paren. Unioned with
5 bracket.
5 to infinity, like this.
Yeah.
We just have to keep them separate. What?
Do you have to have the U there?
What did you put? Comma? What did you put? You just put the 2? That's fine. That's fine. I'm not going to be that picky. Intersect, where do they overlap?
They don't.
Niet. They do not. So circle the line through it. Okay? How about that? Those are the weird ones. Those are the weird ones. They take a little bit of work for that one. Okay? What else you got? Zach, what do you got? Yeah. What did you write? How did you write them? How did you write them?
Y is such that this and that.
Technically, they want it in set notation. Technically, they want that answer. But I wrote them in interval notation. So, technically, you're the only one that did it right. I will take it. Jordan also did it right, okay? You did ask if you could write it in interval notation. Interval notation is easier for me to check, and it's easier for, it's just easier to see. So, that's fine. If you wrote it in set notation, totally fine, okay? What else you got? Questions? What else you got? Anybody else want to see? Did you get all those right for those of you who did that? Yeah, proud of you. Good job. Owen's like, I'm going to shake my head even though that was not true. No, just kidding. You did do it right? Yeah, he copied off of Jacob, and Jacob always does them right. Yeah, you're right. Okay, what else you got? What? Zach? If you need me to, I can help you later too, Zach. If that's better. Anybody else have a question? No? You're good? Okay. All right. That's the only one? Okay. Zach, you want me to help you later? Yeah. I can do that. That's fine. Okay. All right. Well, that was not very exciting. Only one question. But although it had 6 parts to it. Okay. All right. Ready?
Fine. Here you go, Lauren.
Shall we begin the next thing?
Geometry.
What?
That's geometry.
No, it's not. No, it's not.
Oh, well, people said it was geometry.
No, that's not geometry. La la la. I gotta find where we're at here. There we are. R2 exponents. Yes. Love it.
Are we turning this in?
Yes. Yes. Pass them to the middle, or I think they have a pile right here started. Okay. So Addison, don't forget. I will get yours from you when you come back. So don't forget to turn that in. Cool. Okay. All right. Are we ready for R2? Did you guys all find these notes?
No.
R2 exponents and radicals. How big is this? How many pages is this? 1, 2, 3. Is that only 3? Okay, but there's lots of examples, like 9. And on each one there's like an A, B, C, D, E, F, so it will still take some time.
The homework too. Gonna be that.
Like there's quite. Oh, I don't have it on the board. Woo!
That means
I don't know. No, you don't get to choose. Sorry. You want me to write it down
yes.
first? Okay. All right. Page. Blah 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 blah.
Ah.
Trigonometry. That's what we are. Page. Oh gosh, you guys are gonna love this.
Oh, yay.
I'm lying. If you couldn't tell.
I know, you're lying.
Okay.
Oh boy. You're...
I'm not even halfway done yet.
Why can't you like have some order in your problem?
Because I pick the best ones. It takes me a long time to go through the book and figure out which questions I want. And you should be happy because, like, if I were to have gone by, like, let's say 4s or something, you would end up with an ugly problem. So, yeah, it takes you a while to write them down, but these are the very best problems. These are the very best problems. I hand-picked them for you. There you go.
And pick, you said.
I did. I hand-picked them. SCH.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20.
But you have 3 days to do them, so that's like less than 7 problems a day.
H,
Come on.
E, U, R, E, X.
Oh, yeah.
You're missing a lot of letters.
There's an apostrophe.
I don't know. I can't spell it. H-E-U.
What are you spelling?
So where'd they come from
Worry.
to get a last name like that?
I don't know.
Trevin.
H-E-U something. R-E-U-X, yeah. I was missing the R. Okay, are we ready? Did you get them all written down?
No.
Exponents and radicals. Exponents and radicals. Do we know what an exponent is?
No.
Yeah.
I'm just kidding.
An exponent is one of these right here. So like a 3, right? What is a radical? A square root or a cubic root or a fourth root. Heaven forbid we actually have to do that. But how do they go back and forth? They're inverses, kind of, yeah, right? Like, but like, what does what's the square root of x mean?
X divided by X.
Nope, x to the 1/2 power. That's what the square root of x means. What does the cubic root of x mean? To the 1/3 power. What's x to the fourth root of x? To the 1/4 power. So, radicals and exponents are inverses of each other because the 1/2 power and x squared are going to cancel each other off. X cubed and the cubic root, or the 1/3 power, is going to cancel each other off. X to the 4th and the 1/4 power, or the 4th root of x, is going to cancel each other off. So they are inverses of each other, right? Radicals and exponents, they undo one another. But just so you know, the radicals, if they have the square root, that means x to the 1/2, the 4th root, whatever, right? Okay, for those of you still writing that down, you just keep writing. What is
X to the half power.
the cubic root of x squared?
2x. X.
2/3 power, right? Okay? So the root is always the radical. The exponent, the top number, is always the power, right? Got it? What if it's the square root of x to the 5th power? What's that? Still 5/2, right? That is 5/2, and this is 5/2 because it doesn't matter what order you go in, right? You could take the square root first and then to the 5th power, or you could take to the 5th power first and then square root. It doesn't matter which order you go in. They are commutative. Okay, we learned that. No, that wasn't in your class. Never mind. What? Oh yeah, it was.
Then
Yeah, it
you
was.
have the square root of x to the 4th power. Then would it be?
Squared. X squared, right? The square root of x to the 4th power would be x to the 4/2 power, or x squared, right?
That's what I'm talking.
Because the square root of x to the 4th power comes out nicely. It's x squared, right? Yeah. Okay. Good questions. Good questions. Okay. All right. We've got some weird things that happen, and that is like anything to the 0 power is.
1.
Jacob was trying to tell us yesterday. We were talking about that, right? Okay. Because you got a little confused about something to the.
What about the 0th power to the 0th power?
I understand.
I think it's still 1. I think it's still 1.
I understand.
Well, let's plug it
It's
in.
like
What?
taking it to the reciprocal, right? So like
0 to 0.
I.
I don't know what
it
you're
would
saying.
explain, like,
Air.
5 to the 0.
I get air.
5 and 1 over 5.
What about negative 1?
Sure.
Miss Coacher, I got.
Would be -1. Okay. Here you go. Okay. Zach just asked this. -1 to the 0 power, like that, is
1.
1. -1 to the 0 power is
Negative 1.
-1. Because in this one, the only thing that you're taking to the 0 power is the 1, and then you're just like attaching the negative on front. Okay? For the same reason that -2, let's go -3 squared and -3 squared. This is +9, and this is -9, right?
Yeah.
Okay? Good questions.
How do you
Good
tell
job,
how much
Zach.
is batteries left on this?
You just, when it's not flashing, it's got enough battery. I don't know. You can't because you have like actual like batteries. Okay. All right, let's go to this one. Negative exponents.
So you can
So
plug
let's
it
say I
in.
have x to the -3rd power. To fix that -3rd power, I make this first and foremost into a fraction, so I put it over 1. Then to fix any negative exponents, I put them the opposite. So this will become 1 over x to the 3rd power, right?
Yeah.
Okay. Now what happens if he's on the bottom and he's like 1 over x to the -7th power here?
So
Then
He would be x to the 7th power on the top over 1, or just x to the 7th power, right? Okay, so you can interchange them, moving them top and bottom, and it will make the exponents become positive, okay?
Right.
All right, now, what if you have something like this, where you have x squared over x to the -3rd power?
Then it becomes the thingy that is.
So I'm going to fix him first. I'm going to bump this guy to the top. He is x to the 3rd power, and then I combine. Is that 5 or 6?
6.
What isn't that? I'm sorry.
5.
That's x to the 5th. When is it 6?
When it's extra on the outside.
This is 6, right?
Yeah.
Okay.
Wait,
We're learning all
why
sorts of stuff.
Did they not switch?
What?
Ow.
What do you mean?
Why did they not switch?
What do you mean? Why did they not switch?
Because we're doing switching like that.
They did.
So this one, if I started with x squared over x to the -3rd, I'm going to move the x to the -3rd to the top to make it x to the +3rd. But since there's already an x there, I've got to combine those two to make it x to the 5th over 1. Right? Because there's no bottom now.
I tried, but it didn't work.
Yeah? Yeah. Maybe? Maybe? What do you mean?
The negatives on the top, so like x -2 over x.
Okay, let's do this. Let's say I have x2 over x3. Now what? When they're both positive.
Or no,
Actually, let's do negative. Let's do negative for both. -2, -3.
Negative.
What do you just switch?
Oh, then it would just
You can switch both the top and the bottom, so now it's x3 over x2, right? Or I could just take the bigger one, leave this as x -2, move the x3 to the top, right? So what's x -2 and x3? X to the first, right? Because -2 plus 3 is that, right? If I switch them both, it's x3 over x2. What's x to the 3rd divided by x squared? Just x, right? That was a lot. Was that a lot?
Yeah, go
Yep.
no.
Okay, that's like all this stuff right here, right?
Okay.
Okay, we'll get to that. We'll do some more examples of that. Okay, so A, what can we do to simplify A?
It equals
Y to the first power is 1, so it's like 6 times 1, which is 6. Okay, we just talked about that one. What about negative 5 to the 0?
Negative.
It is negative 1 because the only thing you're taking to the 0 power is the 5, which is 1, right? Then attaching the negative on the front, so that is negative 1. What about this one?
Negative 1.
no.
Is that this one?
It's like over 1, right? So if I make him,
25.
Yeah.
so he is now 1 over 5 squared or 1 over 25 if I bump him to the bottom.
Yeah.
Okay, we're going kind of fast. If you are stuck, you just have me slow down.
P to
Okay.
the quattro.
I'm going to bump him to the top. Okay, so p to the 4th power is now on the top with 1 on the bottom, or just p to the 4th. Okay, on the top. Holy moly. All right, now. Okay, some people are going to do this wrong. Is everybody watching? I'll show you what you do wrong.
Oh, I know what to do.
What are you moving?
You move into 5x.
No, you don't.
Is it just
Why not?
aren't they stuck together? Aren't they like one thing?
There are like 3 pieces, right? There's a 5, an x, and a y, right?
Yeah.
But they each can go individually. The 5 is not attached to the y for the same reason that or 5 is not attached to the x for the same reason that y is not attached to the x. The y gets to stay. The 5 gets to stay, right? That's the thing that I see people, they want to move the 5 and the x. The 5 is not to the negative 8th power, right? The 5 is technically to what power?
1.
The first power, right? So if that helps you, he gets to stay up top. So what stays on top?
5y.
5y squared. X to the 8th gets bumped to the bottom, okay? So those coefficients get to stay. They are not also, now, if they would have said this, that is when you move both, right?
Okay.
Okay? That's when the 5 would go with, all right? But they are not attached. They're multiplied, which means you can pull them wherever you want, right? Okay, good? All right, here we go. So, here's a property, and I kind of ran over all my stuff, so let me erase. Can I erase?
No.
Yeah, sure. Here we go. Let's say for this one, we have let's go x. X to the 3rd times x squared. We already said that one was x to the 5th because you add the exponents, right? X to the 3rd divided by x squared is x to the 1st because you subtract the exponents, right? Okay. X to the 3rd squared is x to the 6th. Do you know why?
Because they're multiplying.
What does it mean to square something?
Take it times.
Take it times itself. So this technically means x cubed times another one of him, right? And in that case, you add them, and that is x to the 6th, right? Does that make sense? That's another way of thinking about
Can
it.
you just multiply the two numbers on top, or does that not always work?
What do you mean? These two?
Yeah.
Yes, always.
What if you add another square to the square?
Then you multiply that also. So like what if it's x cubed squared?
Yeah.
12. Yep, exactly. Yep, x to the 12th power. X to the 12th power. Okay. All right, this one says, let's say I have a b to the 4th power. That means the a and the b are to the 4th power. So if you want to simplify and not have any parentheses, he is a to the 4th, b to the 4th. Right? Like that power distributes. Because what is the exponent on a and b down here? 1, right? So I multiply 4 by 1, 4 by 1, right? So it's a to the 4th, b to the 4th. Same thing if a is on top of b, right? Let's say I have a, I'm going to do a little bit different. Let's say I have a squared and b to the 3rd, and I have a 4th power. Now what is he? A to the 6 or 8? 8. And b to the 7 or 12? 12. Because you're multiplying, right? Okay.
There was no parentheses or A and B together then.
If there's,
If it was just A, B to the 4th.
if it was just a b to the 4th,
Yeah.
like this, no
Then
parentheses,
they're together, right?
no.
No.
No, it's just
Then, if that's the case, then the only thing that's to the 4th power is b, and a is to the 1st. Yeah? Okay. Good? All right, here we go. This is where it gets messy because we got lots of things going on. Simplify. Write the answers with positive exponents. So we got to fix all those. All right. What would you like to do first. I don't want to do that. I want to simplify the stuff inside of here because I see numbers, A's and B's that I can fix, right? Okay? So I'm going to deal with the negative 2 after bit. Here I've got 14 and 2 becomes 7 and 1, right? So I'm just going to make 7. Okay, I have 2 A's on the top and 5 B's on the bottom. All right, if you're new to this, I have 2 A's on the top and 5 A's on the bottom.
So it'd be 3
Boop,
down
boop.
the bottom.
So 3 A's on the bottom, right? Okay, if that helps. If it helps to think about it in terms of that, we have 3 A's on the bottom. All right, B's, I have 7 B's on the top
And 1 B on the bottom.
and 1 B on the bottom. So I have 6 B's on top. All right, now, this is the tricky part. Are you ready? Are we to this point? Boys, are you paying attention? Dilly needed to watch this.
We're watching, don't worry.
This is where we get lost.
No, we
Okay. We want to deal with the negative 2. I do not want to distribute the negative 2 through.
Right.
I want to get rid of a negative exponent. So here's the deal. When you have a negative exponent, they flip-flop. Right? So, let's do this. I'm going to make this a cubed 7b to the 6th power, and now it is to the positive second. Does that make sense? So I flip-flopped it. Now I don't have to worry about any negatives. Okay? Now I'm going to distribute the 2 through. Now, again, you can do a different thing. I'm just telling you to do the easiest thing.
Wouldn't everything be negative?
If we would have done that, then everything would be a negative, right?
Then you flip that.
But then you would end up flipping it. Okay, so I just flipped it first, and now I'm only distributing a positive 2, right? So he will be a to the 6th over 49, because it's 7 squared. B to the 12th. As you're multiplying. Okay? Now again, you could have gone to the first part and distributed the negative 2 through. But I would not really want to do 14 to the negative 2nd power. Like, that seems ugly. Okay? All right, so B, let's talk about what we'll do first on B. What shall we do first on B?
Make it a fraction.
Make it a fraction. I like that idea. Okay, so what goes on the top of my fraction? 4x to the negative 2y cubed. That is all to the 3rd power. On the bottom, negative 3x to the positive 4th power, if he's on the bottom now.
Oh.
Now, can I cancel my x's and stuff here and all the things? Because 1 is to the 3rd power, 1 is to the 4th power, right? Like over here, I could cancel stuff. But I can't do that because 1's to the 3rd, 1's to the 4th there, right?
Oh.
So, shall we... We got to do this first. Right? We got to do that first. Okay? What is 4 to the 3rd power?
It's negative 4.
No, it's not. If we move it to the bottom, it's positive now. Right?
4 to the 3rd.
Oh, because it's all be on the top.
Wait, which
Okay?
one are we doing?
So we're doing this top part right here. 4 to the 3rd power. This guy. He is 64.
Yeah.
Okay? X to the
X to the negative 6.
negative 6th. Y to the
Y to the 9.
9th. Okay? Then on the bottom, what's negative 3 to the 4th power?
So it should be positive.
It should be positive.
27.
No. What's 3?
81.
Negative 3 to the 4th power is 3 times 3 times 3 times 3. This is 9. This is 9, right? 81. Positive 81.
Yeah.
X to the 4th. All right, we are almost done. 64 and 81. Can I reduce those? Can I do this?
Divide by 3.
Can I do that? To make that 8 and 9?
Sure.
No. I can't insert a square root in there, right? If there's not already one. 64 and 81. Nothing will divide by them, so they stay. 64 and 81. All right, what are you going to do now?
The X is
X to the negative 6 is going to bump down here. He's going to be X to the positive 6. And that is? Oh, that's a Y. I don't know why I did that. Y to the 9th on top. 81 X to the 10th on the bottom. Are we done?
Well, unless you want to.
I feel like you can divide that by 9 somehow.
Nope.
No.
64 doesn't divide mine.
63 is
Nope, that's all.
Yup.
Can't simplify. Okay, these get a little messy sometimes.
I'm sweating.
They get a little messy. Are we sweating yet?
Yep.
Woo! Okay, do we know how scientific notation operates? Yeah. Okay, so this is 45 million. When we have 45 million, we want to first
That's a couple bands.
put them in scientific notation. We have to have a number between 1 and 10. Did they tell you that when you're doing scientific notation? Okay, so a number between 1 and 10 would be 4.5, right? That's going to be my first number. All right, so if I put my decimal here, I have to move the decimal 1, 2, 3, 4, 5, 6, 7, right? 7 places, so it's 10 to the 7th power. Yeah? Okay. Over here, this guy, I want to put 5, because that's my number between 1 and 10, so 5.0. So if I move my decimal here, I've got to go 1, 2, 3, 4, 5, 6, right? But it's -6, because if I put him there, to the negative is going to move him back this way, right? So if I'm making him smaller, I want him to be to a negative power, yeah? Okay, -300, I'm going to start with -3, okay? And I'm putting my decimal there, so 1, 2 times 10 to the 2nd power. Have we all done that before? Yes. I kind of went really, really fast through that. Casey, have you done that before? Have you done that before? Scientific notation?
A couple times.
Yes, okay. All right, so this guy, write this in scientific notation. You're going to start with the number 2, right? And you can go 2.0 if you want to, so we know the decimal is now here, right? Times 10 to the 1, 2, 3, 4, 5, 6, 7. 7. And it's negative because if we want to put it back together, we've got to go that way. Woo! 230. That's million. That's thousand. That's that. That's 230 billion. So what number are you starting with? 2.3. So my decimal's here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes. Times 10 to the, is it a positive 11 or a negative 11? Positive 11 because I'm making it bigger.
That is insane.
Okay. All right. Now they want to write that in regular notation. So 1, 3, 6. If I move the decimal 7 places, 1, 2, 3, 4, 5, 6, 7. How many zeros? 5 zeros because we have 2 numbers that we've got to account for. 1, 2, 3, 4, 5 zeros. 13,600,000. Okay. Now I'm going -3, so I'm gonna start with my decimal and I'm gonna move it to the left. So I have 0.0039. Okay, 0.0039. We like it. We like it. Okay, now really quick.
We don't have a lot of time.
What time is it? We have a lot of
Bro, we
time.
got like 20 minutes.
That's not
I'll
10
stop.
o'clock
I'll
yet.
stop at a good spot. Where are we at here?
Can you keep on
Aren't we on example 4?
Yeah, we'll do example 4. Okay, a light year is the distance light travels in 1 year. And it travels, if light travels at a speed of 6.7 times 10 to the 8th mile per hour. That's like insane. That's like a lot.
That's, yeah.
How far will it travel in 1 year, which is this many hours? How do I do that?
Put it in my calculator.
This is miles per hour, right? And I'm going this many hours.
You want to know how
I want to know how far.
You plug that in for the hour.
Who makes that?
Kind of, yeah.
Put them, yuck. Is that the eraser or the point?
This is how, if I'm going 50, if I'm going 50 miles per hour for 5 hours, how far have I gone?
250.
I've gone 250 miles, right? So what I do? Multiply. Okay, so I want to multiply those together. Now, how do I do it? 6.7 and 8.76. I'm going to multiply those together first.
Oh my gosh.
What is 6.7 times 8.76?
50.6.
No.
58.7.
Oh.
0.7 what? Give me all of
Say
it.
692.
7692?
No, 692.
692. 692. Now, I know that's not in scientific notation yet. We'll fix it. We multiply those together. If I take 10 to the 8th times 10 to the 3rd, he is now 10 to the 11th because I'm adding those exponents, all right? Okay, so if I were to take this out of scientific notation, I would move it this way 11 places, right? Okay, so I need to make this 5.8692. So is it going to be times 10 to the 10th or 10 to the 12th? Because I need to move it one more place, right? Okay, so it's got to be to the 12th
Where
power.
does 7 come from?
What's 7?
What?
That's 5 trillion.
Oh, and that is how many? Miles.
7.
Don't we need to plug it in then?
No. How far will it travel in that many years?
Oh, we can figure it out.
Nope.
Are we done? Homework?
Sure,
Yes.
we can be done.
So,
I've given you a lot.
What do you
Okay,
think we can do?
so learn, evaluate, nth roots. We got every through that except learn, evaluate, nth roots. Learn, evaluate, nth roots is up through 70. You should be able to get up through 70. So 66 is the last one you should be able to do. Almost half. Okay? So you can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 problems. You can do those first 10 problems. Okay? All right? And we're stopping early, so you should have time to work on it. Okay?
Oh, 54.
All right.
the middle one.
Was that super fast, Casey? No? Okay. I have these guys all in Algebra 2 and we went over this stuff, not like as hard of problems as these. So I know that they should know this, but I never had you in Algebra 2, so I apologize. Okay. Okay. All right. If you have questions, you ask me though. I will make sure I don't go too fast for you. What?
Same here.
Yeah, yeah. And you sent some too?
There's
Okay,
two
Charlie,
things.
take my turn.
All right. Bye, Addison.
ELA.